Okay, in this last recording for the momentum worksheets, we're looking at conservation momentum and collisions again, and it's just kind of practice about using these equations and kind of using the law of conservation momentum formula yet again. So they give us all of our knowns already, all of our givens, the mass of the club head, mass of the golf ball, club head before the collision, club head after the collision, and they tell us that the golf ball is stationary, so near the initial velocity of the golf ball is going to be 0 meters per second. So they already gave us our givens. Now, these are our unknowns. So they want us to calculate out the momentum of the club head before the collision. So we're just going to use momentum is equal to mass times velocity. So we're going to take the mass of the 0.35 kilograms, and you're going to multiply that by the velocity of 38 meters per second. And when we do that, we're going to get 13.3, roughly, kilogram meters per second. We want to know the momentum of the golf ball before the collision. Well, we know the mass of the golf ball, and then we can just do this. P is equal to m times v yet again. So that's that 0.046 kilograms, but it really doesn't matter because the initial velocity is 0 meters per second. So that's going to be a nice, easy 0 kilogram meters per second. We want to find the momentum of the club head after the collision. Well, again, we're going to find momentum, so it's mass times velocity. We know the mass of the club head, that's at 0.35 kilograms. And we know the velocity after is 29 meters per second. So it's slowed down a little bit, transferring some of its momentum to the golf ball. And that's going to give us a total of 10.15 kilogram meters per second. Now for the second one, they want us to find, or the next one, they want us to find the momentum of the golf ball after the collision. Well, we've been doing P equals m times v for all this, but we don't know the speed or the velocity of the golf ball after the collision. So instead now we're going to have to use loco P, so law of conservation of momentum, where the total momentum initial is equal to total momentum after. So P1 initial plus P2 initial is going to equal P1 final plus P2 final. And I knew this because there were two objects before the collision and there's two objects after. So I can just put these in. I've got my 13.3 kilogram meters per second plus 0 kilogram meters per second, the momentums of the club head and the golf ball before the collision. And I know the momentum of the club head after is 10.15 kilogram meters per second plus P2 final. So P2 final, that's the momentum of my golf ball. So I'm just going to subtract those. And I'm going to get 3.15 kilogram meters per second as my momentum of my golf ball after. Now I can use P equals m times v in order to find the speed of the golf ball afterwards. So I'm going to take my 3.15 kilogram meters per second is equal to my mass, which is that 0.046 kilograms, times my velocity. And so my velocity is going to end up being, hang on, let me do this. My velocity is going to end up kicking out to be 68.5 meters per second. So pretty gosh darn fast. Okay, that was a good hit. All right, the next one and final, we're given the following data about the bowling ball hitting a stationary bowling pin. So again, they give us kind of all givens, the mass of the bowling ball, mass of the pin, speed of the bowling ball before and after the collision. And so once again, we're going to do the same thing, momentum of the bowling ball before the collision, so just P is equal to m times v. So I'm going to take the mass of the bowling ball, so that's 7 kilograms, times its speed beforehand, which is 11 meters per second. So that's going to give me a whopping 77 kilogram meters per second. The moment of the bowling pin before the collision, well, it says that it's stationary, so we know the initial velocity, V2 initial, is going to equal 0 meters per second. So again, I don't really have to go through this because I know that this 1.5 kilograms times 0 meters per second is still going to give me 0. But, you know, I did it just for fun. 0 kilogram meters per second. Now, it asks me for the moment of the ball after the collision. Again, so I'm doing P is equal to m times v here. And this would be P final, so P1 final. So I'm going to take my mass of 7 kilograms, and I'm going to multiply that by my 6 meters per second, and that's going to give me 42 kilogram meters per second. Now, they asked me for the moment of the bowling pin after the collision. We run into the same issue we did before. We don't have the velocity of the bowling pin after the collision, so I got to go through my law of conservation momentum. The sigma pi is equal to sigma pf. And a quick reminder, that sigma means sum of. So we've got P1 initial plus P2 initial is going to equal P1 final plus P2 final. Again, the reason for that, we know two objects before, two objects after. So we've got 77 kilogram meters per second plus 0 kilogram meters per second is equal to 42 kilogram meters per second plus P2 final. So I can subtract those and get a grand total of 35. So P2 final is going to be 35 kilogram meters per second. That's momentum. So 35 kilogram meters per second. And now they want me to find the speed of the bowling pin. Again, I'm going to go back and use the P is equal to M times V. I know that my momentum is 35 kilogram meters per second is equal to the mass. So I know the mass is 1.5 kilograms. And I can solve for V. This is be V2 final. And so V2 final is going to end up being 23.3 meters per second. So hope that helps. And if you have any questions, again, come see me. All right, everybody have a great night. We'll see you later. Bye.